Hi students, today we are going to see finding inverse Laplace transforms using convolution theorem. First of all, definition of convolution of two functions. Convolution of two functions, if f of t and g of t are two given functions, then the convolution of two functions is defined as integral 0 to t f of u g of t minus u into du, which is denoted by f of t star g of t. That is, convolution of two functions can be denoted as f of t star g of t, which is equal to integral 0 to t f of u g of t minus u into du. Our f of t, t can be replaced as u. In g of t, t can be replaced as t minus u. When two functions are given, we can use to evaluate the functions using convolution. Theorem, convolution theorem statement. If f of t and g of t are two given functions and f of s, g of s are Laplace transforms of f of t, g of t, then the Laplace transform of convolution of two functions is equal to product of their Laplace transforms. That is, Laplace transform of convolution of two functions f of t star g of t is equal to product of their Laplace transforms. Here the corollary is we are defining inverse Laplace transform for this convolution theorem. L inverse of f of s into g of s is equal to f of t star g of t. We know that f of t is L inverse of f of s, g of t is L inverse of g of s. Here using this convolution theorem, inverse Laplace transform, we are going to find inverse Laplace transforms. Problem number 1, determine L inverse of 1 by s square plus a square whole square using convolution theorem. Here we know that L inverse of f of s into g of s is equal to L inverse of f of s star L inverse of g of s. Now this 1 by s square plus a square whole square I am splitting as two functions. Here 1 by s square plus a square into 1 by s square plus a square. The first one I am taking as f of s, second one I am taking as g of s. Here this is nothing but L inverse of f of s star L inverse of g of s. Here f of s is 1 by s square plus a square, g of s is 1 by s square plus a square. Now we need to find L inverse for this function. This is nothing but, we remember the formula, s square plus a square means numerator should be either s or the constant. Here there is no s, it should be a, but there is no a, so multiply and divide by a. So 1 by a into L inverse of a divided by s square plus a square is sin 80. That only I am writing as sin 80 by a. Here also the same as multiply and divide by a. So 1 by a into L inverse of a divided by s square plus a square is sin 80. That only I am writing as sin 80 by a. Here I am considering the first one as f of t, second one as g of t. So f of t star g of t. Now we are going to apply the convolution definition. Integral 0 to t f of u g of t minus u. In t replaced as u, in t replaced as t minus u. So sin au by a, sin a of t minus u by a into du. This is definition of convolution of two functions. F of t star g of t is nothing but integral 0 to t f of u g of t minus u into du. This only we are applying here. Now this a into a 1 by a square, integral 0 to t, here this is I have to integrate sin a sin b. We know the formula. What is sin a sin b? 2 sin a sin b is nothing but cos of a minus b minus cos of a plus b. Here what is your a gamma? A is au, b is a of t minus u. Here I am subtracting this cos of a minus b. So au minus at plus au. So au plus au is 2au minus 80. So cos of a minus b is 2au minus 80 minus cos of a plus b. Au plus 80 minus au minus au get cancelled. Then we are getting cos 80 into du divided by 2. That 2 I am taking outside. So 1 by 2 a square into integral 0 to t. I am splitting the integral 0 to t cos of 2au minus 80 into du minus integral 0 to t cos at into du. Here I am going to integrate with respect to u. So 1 by 2a square. So cos integration is sin 2au minus at divided by u coefficient is 2a. So the limit is 0 to t. Here integrating with respect to u, at is cos at is constant. So I am taking outside, du integration is u. The limit is 0 to t. So 1 by 2a square. Here applying the upper limit, u is t means 2at minus t is at. So sin at by 2a. Then I am applying the lower limit. Here minus, and then here what I am substituting 0. Sin of minus theta is minus sin theta. So I am getting plus here. So what we are getting, sin at by 2a. Here the next step. Here I am applying u is upper limit is t. So t cos at. Lower limit I am substituting 0 into anything is 0. So this is 2 times of sin at by a. So 2 get cancelled. The next step I am getting sin at by a. So minus t cos at. So I am taking a outside. So 1 by 2a cube into sin at minus at into cos at. Therefore L inverse of 1 by s square plus a square whole square is equal to 1 by 2a cube into sin at minus at cos at. This is the first problem. Next we are going to see the second problem. Use convolution theorem, determine L inverse of s by s square plus 1 into s square plus 4. Here convolution theorem we know that. So L inverse of f of s into g of s is nothing but L inverse of f of s star L inverse of g of s. Here I am going to split this function. In any way we can split. First s by s square plus 1 into 1 by s square plus 4 we can split, or 1 by s square plus 1 into s by s square plus 4 we can split. Here I am splitting as first one I am taking as 1 by s square plus 1 into s by s square plus 4. So first one I am considering as f of s, second one I am considering as g of s. The formula is L inverse of f of s star L inverse of g of s. So 1 by s square plus 1. What is the formula? A by s square plus a square. Here a value is 1. That is sin at. So that answer is sin t. A value is 1. Here s by s square plus a square. What is the formula? It is cos at. Here a value is 2. So cos 2t. Here f of t star g of t. Again I am going to apply the convolution formula. F of t star g of t is equal to integral 0 to t f of u g of t minus u. So in f of t, t can be replaced as u. In g of t, t can be replaced as t minus u. Here integral 0 to t, f of t, t can be replaced as u. F of t is what? Sin t. T replaced as u. So sin u. Then the second function, we have to replace t as t minus u. So cos of 2 into t minus u into du. So I have to integrate this sin a cos b. What is the formula I have to use? 2 sin a cos b is nothing but sin of a plus b plus sin of a minus b. So here a is u, b is 2t minus 2u. So sin of a plus b, u plus 2t minus 2u. So minus 2u plus u, what you are getting? Minus u. So sin of 2t minus u plus, this is sin of a plus b. This is sin of a minus b. So u minus 2t plus 2u. So 2u plus u is 3u minus 2t. This is sin of a plus b. This is sin of a minus b. Divide by 2 into du. So I am taking 1 by 2 outside. Sin integration is minus cos. So minus cos 2t minus u divided by u coefficient is minus 1. Here sin integration is minus cos 3u minus 2t divided by u coefficient is 3. So applying upper limit and lower limit. Upper limit is t, lower limit is 0. Here 1 by 2. Upper limit you are substituting t means 2t minus t is t. So you are getting minus minus plus cos t. And then here I am applying upper limit means 3t minus 2t is t. So minus cos t by 3. Lower limit when I am substituting minus minus plus, lower limit 1 minus. So cos 2t. Here minus, lower limit 1 minus plus, here I am applying 0. Cos of minus theta is cos theta. So cos 2t by 3. I am doing the simplification 1 by 2. Here 3 cos t minus t is 2 cos t by 3. Here minus 3 cos 2t plus cos 2t is minus 2 cos 2t by 3. So I am taking 3 outside. Here 2 outside, 2 get cancelled. So 1 by 3 cos t minus cos 2t. So therefore L inverse of s divided by s square plus 1 into s square plus 4 is equal to 1 by 3 into cos t minus cos 2t. Thank you.